Alright guys, so now we are going to talk about the section 2.4. It is very important that you must remember the definitions, the rules, and that is very important. So let me show you how you can use what you know and how you can find the solution. So when you look at the example number 1, you have absolute value of x plus 4 equal 8. That should remind you that the absolute value of an algebraic expression equal a, and you know that it's supposed to be x equal a. Well, it's not x, the algebraic expression, or the algebraic expression equal negative a. Therefore, if I'm going to put that just below, x plus 4 equal 8, well, that means x plus 4 equal 8, or x plus 4 equal negative 8. By subtracting 4 both sides of each equation, end up to have x equal 4 and or x equal negative 12. The set of solution is going to be negative 12, 4. By the way, I could totally write the set of solution could be written also for negative 12. Okay? The set of solution does not represent the number line. It is just a bag where inside you have two specific values of x. Now let's take a look at example number 2. In this example number 2, what do we have? We have an absolute value of 3x minus 9 minus 2 equal 13. Well, if you try to say again, what does that remind me? Well, you cannot say it reminds you absolute value of x or algebraic expression equal a, because when you look at this expression right here, the absolute value is standing by itself. Therefore, if it's standing by itself, you must transform this into an absolute value standing by itself in order for you to use that relation. So, and therefore able to write x equal a or x equal negative a. So I'm going to add to both sides in order for me now to have 3x minus 9 equal 13. And now definitely I can write, I'm going to keep the same color, I can write 3x minus 9 equal 13, or 3x minus 9 equal negative 13. So when I add 9 both sides, add 9, first I'm going to have 3x equal 21. And for the other one, I'm going to have 3x equal negative 4. Therefore, I end up to have x equal 3 divided by 3 both sides, or x equal negative 4 divided by 3. Two value of x, the set of solution is going to be 3, negative 4 over 3. I could have wrote negative 4 over 3 and 3 for the set of solution. Example number 3. On the example number 3, we could definitely say, hey, that reminds me this with a equals 0, so I'm supposed to have x equal a, the algebraic expression equal a, or the algebraic expression equal negative a. In that case, a equals 0, so I could write x plus 5 equals 0, or x plus 5 equals negative 0. It doesn't make any sense. So basically, when you have absolute value of the algebraic expression equals 0, you can directly write the algebraic expression will be equal to 0, period. Therefore, the only solution is going to be x equal -5. Okay. The example number 4, we do have equal a, but in that case, a is negative. That implies, and it's a statement, no solution. Why? Because an absolute value of an algebraic expression cannot be equal to a negative number, because an absolute value is always positive. Alright, so now let's do the example number 5. The example number 5, we have absolute value of an algebraic expression equal the absolute value of another algebraic expression, and that is supposed to be x equal y, or equality between the two algebraic expressions, or x equal -y. So I end up to have 3x plus 7 equal x minus 8, or 3x plus 7 equal -x minus 8. And you will notice what I've done. Because I'm doing -y, I'm putting a parenthesis for y. So I'm going to get rid of the negative by having -x plus 8. And now I'm going to reorganize to have all the variable x on one side and all the variable non-variable on the other side. So I'm going to subtract x, subtract 7, end up to have 2x equal -15, so x equal -15 over 2, and on the other side I'm going to subtract 7. I should add x. See, I made a tiny mistake, so I'm going to add x. So I'm having a 4 right here. And so if I divide by 4, I got -15 over 4. Oh, no, I'm making a mistake. I was right. See how we can make a mistake? I need to subtract for this one x, because it's a plus x. So in order for me to get rid of this x, I need to subtract x. So I was right for this one. It's a 2. 3x minus x equal to 2. And the 2x you divide by 2 both sides. On the other hand, this one I need to add x because I want to get rid of -x by adding x. Okay, and I end up to have 4x equal 1. So x equal 1 over 4. We set a solution 1 over 4 -15 divided by 2. Okay, so now let's try to work with the absolute value, with the inequality, and it's going to be the same idea. That remind me that the absolute value of an algebraic expression less or equal than a number, where we are supposed to have x in between -a and a. Therefore, I'm getting x plus 2 in between 12 and -12. In order to have x standing by itself, I need to subtract by 2 both sides. Because I'm subtracting by 2 both sides, let me try to present that a better way. So I've subtracted by 2 everywhere, and when I'm subtracting, I don't flip my symbol, so I'm going to keep exactly the same symbol. And you will notice that the first thing I'm doing is I'm rewriting my symbol. Then I'm getting x, and on this side I'm getting 10, when on the other side I'm getting -14. If I represent my number line, and let me use my ruler. Okay, I got a ruler, so let's use the ruler to be a bit fancy, right? Oops. So, number line. And if I'm getting my number line, I end up to have 0 right here, so negative 14 is right here, when 10 is on this side. I want to, x is in between, so if x is in between, I know I will be right here. There is an equal, so I will have a bracket, and so I end up to have as a interval notation as a solution negative 14 10 bracket bracket. I'll let you do the problem number 7 and the problem number 8. Please pay attention on the fact that when you are using your law, rule, theorem, they are presented in a way, and when you look at your problem, you should try to find out the same way of representation. Therefore, in problem number 7 and problem number 8, you don't have the absolute value of the algebraic expression standing by itself. Alright, guys, so first of all, what I want to do is represent absolute value of x. Then if I want to represent x plus 2, I know it's going to be a shift, and it's going to be a shift to the right of 2 units because of plus 2. It's going to be a shift to the left because of plus 2. When I shift right left, it's the opposite regarding the sign. So if I represent 1 2, this could be the x plus 2. Then because of the 4, I'm going to have a vertical stretch, and so I'm supposed to have something looking like more like that. Okay, more narrow. This is 4 times x plus 2. And now minus 5, that means I'm going to have a shift down of negative 5. So wait a minute, I made a tiny mistake because I did not represent this one properly. If that is a 0, I'm supposed to be 1 2, I'm supposed to be narrow, and negative 2 right here and negative 2 right there. So very narrow. And now the last one, I need to have that 1 2 3 4 5. There we go. This one is 4x plus 2, and this one is going to be 4 times x plus 2 minus 5. I will let you solve the problem number, example number 2, 3, and 4, 5, and 6 by yourself. Alright, so absolute value inequality, because I will let you rewrite each case, but let me write this case for you. I'm going to have the algebraic expression in between negative a and a, the algebraic expression in between negative a and a, but this time I will have the equal. And for the other one, I'm going to have x greater than a, or x, the algebraic expression less than negative a. And for the other one right here, it's already written. The interval notation associated for this one is going to be negative a and a bracket, parentheses, sorry, because of no equal. Right there it will be bracket, and it's going to be negative a bracket. Finally, when we have negative a, so I'm going to have a negative infinity negative a, parentheses, parentheses, always parentheses with the there we go, union, parentheses, a plus infinity. A parentheses right here. And guys, now I'll let you finish all the other problem until the end, up to the end. Thank you very much, and talk to you in class.